Hello everyone. In this video, we will be studying sequences and patterns in algebra. We will be focusing on the first category or type 1, which is arithmetic sequence. So let us understand what is an arithmetic sequence using an example. So here I have a pattern which is made up of sticks. So as you can see, this is the first pattern of mine, which is made up of 4 sticks. The second pattern is made up of 4, 5, 6, 7 sticks. So the number 7. The third pattern is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sticks. And the fourth pattern, which is here, is made up of 13 sticks. So if we observe something here, when we have a pattern which is here, and when we use the number of sticks that we have used to make the pattern, we get the sequence. So when the pattern is made up of 4 sticks, I write 4 here. When the pattern is made up of 7 sticks, I write 7, and hence I form a sequence. So this is a sequence I form using a pattern. So a sequence is a numerical representation of a pattern. Now, why do I say that this is an arithmetic sequence, or this is a specific sequence known as arithmetic sequence? Basically, arithmetic sequence is a type of sequence which has common difference between each term. Now, the number 4 is known as the first term of the sequence. The number 7 is known as the second term of the sequence. The number 10 is the third term of the sequence, and so the number 13 is the fourth term of the sequence. If we observe, we can see that the terms of a sequence have a common difference. So 4 plus 3 gives me 7. 7 plus 3 gives me 10. 10 plus 3 gives me 13. So when the difference between the terms of a sequence is common, so here my terms are 4, 7, 10, 13, and my difference is 3, 3, 3. So I have a common difference which is 3. Then this type of sequence where we see common difference between terms is known as an arithmetic sequence. And this is the first category or first type of sequence we will be studying. There are many other types of sequences, but to begin with, we always start with arithmetic sequence, which is the most basic type of sequence. So once again, what is an arithmetic sequence? It is a sequence where the terms 4, 7 have a common difference. So the common difference is 3 in this case. Okay, moving on. Let's answer the first question. Draw the next pattern. So if we have to draw the next pattern, we have to observe that the first pattern has 4, second has plus 3, 7, the third has plus 3, 10, the next has plus 3, 13. So the next pattern, which is the fifth pattern, will have again plus 3. So plus 3, which is 16 sticks. So let's draw the next pattern. We have the next pattern 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have the next pattern having 16 sticks, or made up of 16 sticks. So here we have answered the first question, which says draw the next pattern. Write the next term of the sequence. So the pattern is here, and the number that represents the pattern is the next term of the sequence. So the next term will be 16. So my answer is 16 here. What type of sequence is this and why? So the type of sequence is, this is an arithmetic sequence. Arithmetic sequence. And why? This is known as an arithmetic sequence, as each term has a common difference. So as each term has a common difference. And in this case, the common difference is 3. Let's move on to the next part of the question. Write the 100th term of the sequence. So we see that 4 is the first term of the sequence, 7 is the second term of the sequence, 10 is the third term of the sequence, and 13 is the fourth term of the sequence. So on and so forth. We need to move ahead till we go and reach to the 100th term of the sequence. So now the question is, are we going to keep on adding 3 every time? So in that case, the working for this question would be so lengthy and tedious, and we could also do a mistake while doing this question. So if we have to find the 100th term, or even maybe we need to find the 1000th term, what is the method that we use? We use a formula here. So what is the formula we use to calculate the any term? When we say any term, it is nth term of the sequence. So formula for the nth term, which means n can hold any value. In this case, our n will hold the value 100, since we are finding the 100th term. So the formula is a plus n minus 1 times d. Now what does a stand for? A stand for the first term of the sequence. A is the first term. And the first term here is the number 4, as 4 is the first term of the sequence. Therefore, a is equal to 4. And what does d stand here for? D is the common difference. So d is the common difference. Now we are going to find the nth term formula. So we will find a formula where we can find any term number which is represented by n. So first let us find the common formula for the nth term. So we know that we need to replace the a by 4, since a is the first term and the first term is 4, plus n minus 1 will be written as it is. D is the common difference, which is 3. So here we need to add 4, and we need to add it to 3 multiplied by n minus 1. So let's multiply 3 by the bracket n minus 1. So we will multiply 3 into n, which is 3, and 3 into negative 1, which is negative 3. So we have here 4 plus 3 into n and 3 into negative 1. So 3 into n is 3n. 3 into negative 1 is negative 3. We have the like terms here. My like terms are 4 and negative 3, as both of them are constants, which means they don't have any variable. So we can simplify them. 4 minus 3 gives me 1. Therefore, my formula is 3n plus 1. 4 minus 3 gave me 1, and 3n is written as it is. So my nth term formula for this particular pattern above is 3n plus 1. Now, using this formula, I will find the number of sticks in the 100th term. So when I want to find the number of sticks in the 100th term, all I need to do is to replace the n with 100. So I will replace the n with 100. So 3 into 100 plus 1, that is 300 plus 1, and the answer is 301. So the 100th pattern will be made up of 301 1 sticks. So in this way, we can also find, for example, the 1000th pattern, how many sticks it will contain, or any pattern. All we will need to do is to replace the n by the term number that we require to find. So if we want to find the 200th term, we will replace the n by 200 here, and hence we will find the number of sticks used. So this was the first example. Let us move on and try another example. I would strongly recommend that you try this on your own, and then you can play the video and understand if your working is right or not. So here is a pattern made up of squares. So in the last question we had pattern made up of sticks. Now here we have a pattern made up of squares. So the squares are the first pattern, as we can see, is made up of 3 squares, 1, 2 and 3. So the first term of the sequence is going to be 3. Then the second pattern is made up of 1, 2, 3, 4, 5 squares. So the second term of the sequence is going to be 5. And the third term of our sequence is made up of 1, 2, 3, 4, 5, 6 and 7 squares. Therefore, the third term of our sequence will be 7. The question says draw the next pattern. So if I have to draw the next pattern, and since I know that this is an arithmetic sequence, and how do I figure out that this is an arithmetic sequence? Because I add 2 to 3 and I get 5, and then I add 2 to 5 and I get 7. So here we have common difference. So whenever the terms of a sequence have common difference, that is known as an arithmetic sequence. So let's draw the next pattern of the sequence. So the next pattern of the sequence obviously will have 7 plus 2, which is 9 squares. So let's make the next pattern with 9 squares. So we have here we'll start from here. Let's count now the number of squares. We have 1, 2, 3, 4, 5, 6, 7, 8 and 9 squares. And we can also see the pattern looks so uniform and so predicted. So here we have the next pattern with 9 squares. So we've answered the first question, draw the next pattern. Write the next term of the sequence. We have already answered the next term of the sequence is adding 2 to 7, which is 9. So we write the answer as 9. And what type of sequence is this? This is an arithmetic sequence. Arithmetic sequence. And the question is saying, why is it an arithmetic sequence? As there is common difference between each term of the sequence. So 2, 2, 2. So between the terms of the sequence 3 and 5, the difference is 2. Between 5 and 7, the difference is 2. Between 7 and 9, the difference is 2. So the terms of the sequence have common difference. The terms of the sequence have common difference. Alright, so that answers for question 3. Write the 100th term of the sequence. So here again we are expected to find the number that would be for the 100th term of the sequence or the 100th pattern. If we draw the 100th pattern, what would be the number corresponding to it or the number of squares corresponding to it? So we are not going to draw 100 patterns and find the 100th term of the sequence. We will just use the formula, and as we discussed earlier, the formula is a plus n minus 1 times d. This formula is only for an arithmetic sequence. It is strictly for an arithmetic sequence. We cannot use this formula for any other category or any other type of sequence. So as we discussed, A stands for the first term of the sequence. The first term of the sequence is 3. And D stands for the common difference, and the common difference between the terms is 2. So let us plug in the value. We have A, which is the first term of the sequence, which is 3. N minus 1 will be written as it is. D is the common difference, which is the number 2. Now here we need to add to 3 the product of 2 into n minus 1. So let's multiply the bracket n minus 1 by 2. So that's going to give us 2 into n, 2n, and 2 into negative 1, negative 2. So let's work it out. So that will give us 3 plus 2n minus 2. Now the two like terms here are 3 and negative 2, as they both are constants. So we can work out 3 minus 2 gives us 1, and the answer will be 2n plus 1. So this is the special formula for the above sequence. So the special formula for this sequence is 2n plus 1. Now let's move ahead and find the 100th term. So to find the 100th term, all we need to do is to replace the n here by the number 100. So let's move ahead and do that. Our formula for the above sequence is 2n plus 1. If we replace the n by 100, we have 2 into 100 plus 1. So that is 200 plus 1, and the answer is 201.